So good morning, welcome back. I hope you had a lovely 4-day weekend. You got to relax a little bit. Maybe had a nice Valentine's Day. Hopefully everything was good. Before we get into our lesson today, I want to jump over into Canvas and show you guys what is going on in there, what's coming up. So share my screen. Alrighty, so here is our Canvas course. This should be familiar by now. Hopefully it is. A couple things. So hopefully, there's a few things going on here. Chapter 6, we should be past at this point. We should all be in Chapter 7. Hopefully getting ready to work on the assessments for Chapter 7. The Chapter 6 assessments, if you have not turned them in, I put a placeholder grade in there for you on the multiple choice. If you haven't done it yet, it's in as a 0 right now. If you have not submitted the free response question, self-assessment, that's in as a 1 right now. So if it hasn't been done, it is negatively affecting your grade. I wanted you guys to see what that would do to your grade if these things aren't done before the grading period ends on Friday, because that's the end of the first grading period, and I gotta have grades posted and such and things, and they should be a fair representation of how you're doing in the class. So if those haven't been done yet, you can see that in your grade. It's not going to look very good. And if they have, then hopefully you've gotten feedback. So I just want to show you guys, if you've taken the multiple choice quiz, and this goes for the Chapter 6 and Chapter 7, any of them, right? When you go back into the assessment after you've done it, it will show your attempt history. Right? If I click on attempt number 1, which is the only attempt for my test student here, it will actually go through and show each question, what you selected, whether it was correct, whether it was wrong, and feedback based on your answer. All of the questions are set up this way. So you can see like the test student on question number 2 got that wrong. The feedback is designed to help make a correction, right? So if you don't have the score you wanted on the multiple choice, click back into your submission, look at your responses, look at the feedback, try it again. All right. I want you to try and get as many points as possible on the multiple choice, right? You can take this unlimited times. You have unlimited attempts, and the highest score is kept. So it doesn't matter if you go try it again and you get a lower score, the higher one will be kept. All right. So please take advantage of this. Right, and you can take a new attempt here if you like, and you can start a new attempt from that other screen. So there's that. On the get an echo. On the free response questions, right? It will show that this has been it's been submitted and graded, right, across the top here. And if you have multiple attempts, you can scroll through your attempts over here. And then if you go to the bottom under the prompt, right, it will show your attempts. So if you have a file attached, the file should be here. On the test student, they got some written feedback on their work here, right? Some of you got some of that depending on if I was grading on my iPad or on the computer. The iPad allows me to write directly on your pictures, but sometimes it's kind of hard to see. Also, if you look at the comments, many of you got actual just typed up comments about your work. You can see that under the comments. You can also look at the rubric and see where I placed you on the rubric based on your work. Okay, so this is a very important part of looking back at your work and looking at the feedback. If your grade wasn't approved, or if you just didn't do well, look at the feedback, right? I'm usually going to give you an idea of what you could do to improve your grade, right, and improve your understanding. So it's worthwhile to look at, especially if you don't like the grade you have. Look at the feedback. You have unlimited attempts. If you want to submit a new attempt, you'll say new attempt here. You only need to submit the corrections to the problems that you didn't really get correct, right? The things that you want to revise. You don't have to redo the entire assessment unless you need to redo the entire assessment, right? Unless you got it all wrong somehow. All right, so you only need to resubmit the things that you need to correct or that you want to correct. Don't do the whole thing. All right. So please look at the feedback on the assessments. You only have 2 required assignments each chapter. There's the in-class activities that if you're here, you get credit. You don't have to do anything outside of class. These are the only 2 things you have to do every chapter. So please do them. And then try to get better, right? Any questions about the assessments and the feedback and where to go to find that? So then let's look at, take a real quick look at our calendar here. We are halfway through February. Right? The idea for the last couple weeks of February is to cover chapter 8. We have 8.1 this week, 8.2 and 3 next week. And it'll kind of follow the same pattern we have been doing. There'll be a lesson day and then a practice day. So we're going to do that. Next month in March, we have a short month, right? Because of spring break at the end of the month. The first 2 weeks of March will be for chapter 9. And then the last week and a half of that month before spring break is going to be designated for review. It's going to take a look back at all the chapters we've covered so far, important content, practice problems, things like that. I might even do like a little practice AP exam kind of thing for you guys to have a little more experience on that. So deciding what I'll do in the review days. This also provides us with a little bit of wiggle room on the pacing. Whereas if we need more time in one of these other sections in chapter 8 or chapter 9, we can take an extra day or something. All right, so that's the idea up through spring break, what we're going to try to do, and then we'll have, let's see, I think we have chapter 10, 11, 3, and then 12. So 4 more chapters, but get there. All right, so that's the idea for the pacing. And then in our modules, in chapter 7, our chapter 7 assessments are ready for you guys to attempt. And there's the multiple choice and free response. Please start looking at those. Hopefully you can start working on those this week. If these are not turned in by the end of the grading period, they will not negatively affect your grade for this grading period. If you do submit them before the end of the grading period, I will grade them and hopefully they will positively affect your grade. So there's that as well. And then moving into chapter 8, we have the class notes and resources are up, except I don't have the study guide ready yet. I do have a link to the presentation that we'll see today, some examples from the textbook for 8.1, and the textbook information. There aren't any AP Daily videos for 8.1 on that introduction. They just jump right into specific examples and cases with proportions and means, which is in our section 8.2 and 8.3. So I have all those videos for the next section of notes and resources. And then we also do have our practice problems already for 8.1. So you'll be able to access those if you like. I don't have the solutions yet. So that's where we're at in the course. Lastly, and I'll have this other information posted, there's some NIMSY resources. If you're not familiar with NIMSY, it's kind of a national organization that helps support you guys and other schools in passing AP exams. And so you guys should have gotten an email from NIMSY over the last couple weeks that you can use to log into Blackboard, which is similar to Canvas, but it's what NIMSY uses. And you can register for a course. You can do on-demand or live sessions. There's a calendar of live sessions. Again, I'll link this stuff so you guys can kind of look through it. And I'll also, I have a resource that says what the topics are for each day. So you'll be able to look at that as well if you want. So I know there's a lot of just a dump of information at you guys, so I do apologize. I want to make sure that these things are on your radar so you know what's going on. You know, there's some extra resources for you and so on. Is there any questions, comments, concerns about basically the next month of the course? All good. All right. So then we're going to do our lesson for today. So if you have something to take notes on, please have that ready. There's going to be some things you probably want to write down today. So we will get started. All right, so we are in that's not right. There. Sorry guys, my computer decided not to cooperate. There we go, that's what I want. So we're starting chapter 8, estimating with confidence. This piggybacks off of what we have done in the previous 2 chapters with our random variables and sample distributions. And now we're moving to confidence intervals. So today we're going to begin the process of determining the point estimate and margin of error from a confidence interval. We're going to interpret a confidence interval in context, interpret a confidence level in context. Those are 2 different things. Describe how the sample size and confidence level affect the length of a confidence interval, and explain how practical issues like a non-response, undercoverage, and response bias can affect the interpretation of a confidence interval. So first we're going to look at an example. So this is an activity. We're not going to actually do this activity today. I have an example of how this could work out prepared for you guys. So suppose your teacher, Mr. Mosley here, selects a mystery mean value mu and stored it as m in the calculator. Right? Your task would be to work together with 3 or 4 students to estimate the value. The following command was executed on my calculator. Mean parentheses rand norm M 2016. Right, the result was 240.79. This command tells the calculator to choose an SRS of size 16 observations from a normal population with mean M and standard deviation 20. The resulting sample mean of those 16 values was 240.79. So that's what this command does. Now, obviously, the calculator knows what M is, so it actually treats it like a number, not a letter. That's beyond the point. Right. Your group would attempt to determine an interval of reasonable values for the population mean mu. So you're not trying to nail it like this is the value, because we don't have enough information to do that, but we can hopefully determine a range of values that are reasonable to say, well, the mean is probably within this range. Right? Use the result above and what you learned about sampling distributions in the previous chapter. So here is one possible way to deal with that. So in my scratch work here, you can see that M, we don't know what it is. We use this command, right? And this uses a sample size of 16, an SRS of 16. I don't know the mu. Standard deviation of 20 for my population. And we end up with an X bar, a sample mean of 240.79. We can assume this is an unbiased estimator of mu because we have nothing else to go on. So based on that assumption, we can, and the fact that 10% condition will be met because we're dealing with an infinite number of possibilities, right? So, because the population is an infinite amount of numbers, right? We get a standard deviation for the sample mean of 5, because the standard deviation of the population is 20, sample size n is 16, 20 divided by square root of 16 is 20 divided by 4, we get 5. I then say, well, I know that pretty much all of my data in a normal distribution, as I started with the normal distribution, so my sample distribution is also normal. Most of my data is within 3 standard deviations. That covers 99.7% of my data, so pretty much all of it. So I multiply 5 by 3, because that's 3 standard deviations to the left or right of mu for the spread. So I add that to my mean of 240.79 and get 255.79. Subtract it from my mean, get 225.79. So I'm saying an interval of reasonable values for population mean mu is between 225.79 and 255.79. It's a pretty big spread, but I can say with a good degree of confidence that the mean is somewhere in there based on the data I have. So this is, we're using the stuff that we've already done with random variables and with sample distributions to put this together. We're piecing together the puzzle. Is there any questions about what I did here in this example? Anything I can clarify? Right. It started over. Why did you start over? Okay. So let's continue. So if you had to give one number to estimate an unknown population parameter, what would it be? If you're estimating a population mean mu, you'd probably use X bar. It's the best we have, right? If you're estimating a population proportion, P, you might use P hat. Again, it's kind of the best thing we have to go with. In both cases, you would be providing a point estimate of the parameter of interest. A point estimator is a statistic that provides an estimate of a population parameter. The value of that statistic from a sample is called a point estimate. So the point estimator is the type of statistic, so like X bar or sample mean or sample proportion. The actual value is the point estimate. We learned in chapter 7 that an ideal point estimator will have no bias and low variability. Right? The ideal point estimator is the ideal unbiased estimator. Since variability is almost always present when calculating statistics from different samples, we must extend our thinking about estimating parameters to include an acknowledgement that repeating sampling could yield different results. That's why we have a range of possible or probable values that the mean could be. It's not like, hey, well, this is exactly what it should be because that's what my estimator is. We know that there's a varied amount of responses we get when we sample. Does anyone need a moment to write anything down from this page? So in our activity, is the value of the population mean mu exactly 240.79? No, probably not. However, since the sample mean is 240.79, we could guess that mu is somewhere around that mean of 240.79. How close to 240.79 is mu likely to be? Well, we have to answer this with another question. How would the sample mean x bar vary if we took many SRSs of size 16 from the population? Oh, so we're going to do a sampling distribution. Right, now we're back in chapter 7. We start with our population, which we have a unknown mu, standard deviation of 20. We take a whole bunch of simple random samples of 16, we get different x bars, right? Get a whole bunch of sample means, and that creates our sampling distribution of x bar. Based on what we know the standard deviation of the sampling distribution. We still don't know the mu, but we know the standard deviation, and we have x bars to work with. But again, we get this much more narrow set of values to work with now. Right? It's very typical that we go from the population, which may be much more varied than the sampling distribution. So it gives us a more precise idea of what the mean could be because this is a much more narrow field. Does anyone need a moment to write anything down? Okay. To estimate the mystery mean mu, we can use x bar equals 240.79 as a point estimate. We don't expect mu to be exactly equal to x bar, so we need to say how accurate we think our estimate is. In repeated samples, the values of x bar follow a normal distribution with mean and standard deviation 5. Again, there's no value placed on mean because we don't know exactly what it is. The 68, 95, 99, 7 rule tells us that in 95% of all samples of size 16, x bar will be within 10 2 standard deviations of mu. If x bar is within 10 points of mu, then mu is within 10 points of x bar. Because if x bar is an unbiased estimator, then they should be equal, which means they're within the same range of each other. Therefore, the interval from x bar minus 10 to x bar plus 10 will capture mu in about 95% of all samples of size 16. Right? So this is kind of important, the verbiage here. It's saying that, like, so in my sample size of 16, the range of that sample size will cover the actual mu, the value of my parameter, 95% of those samples, in 95% of those samples, which means some of them might not, but pretty much all of them will. If we estimate mu lies somewhere in the interval 230.79 to 250.79, we'd be calculating an interval using a method that captures the true mean in about 95% of all possible samples of this size. We'll see a visual of what that kind of looks like and what it means in a little bit. Is there anything I can clarify so far? Does anyone need a moment to write anything down? All right, so then we go to the idea of a confidence interval. All right, we have the estimate plus or minus the margin of error. A C% confidence interval gives an interval of plausible, not possible, plausible values for a parameter. The interval is calculated from the data and has the form point estimate plus or minus the margin of error. And this is important, the use of the word plausible and not possible. Possible is a much wider range than plausible. Plausible is the things that are reasonable. Possible is like, well, it could be any of these things. It could be the whole range of values that's much larger than the plausible values. The difference between the point estimate and the true parameter value will be less than the margin of error in C% of all samples. The confidence level C gives the overall success rate of the method for calculating the confidence interval. That is, in C% of all possible samples, the method would yield an interval that captures the true parameter value. Right. So the confidence interval is the plausible values, that like range of plausible values. The confidence level is like the success rate, the percent of the possible samples that are successful in capturing the true parameter value. Okay. So we need a moment to write anything down. Please raise your hand. So the confidence level is the overall capture rate if the method is used many times. The sample mean will vary from sample to sample, but when we use the method estimate plus or minus margin of error to get an interval based on each sample, C% of these intervals capture the known population mean mu. So again, in a visual here, we start with our population. We take a lot of SRSs. We get many confidence intervals. 95% of these intervals capture the unknown mean mu of the population. Visually, it looks something like this. We have our sampling distribution of X bar, the sample means, and then we have the interval of each SRS, with the red dot here representing the mean. We can see the true parameter value mu running through the middle here, and most of our ranges on our sample SRSs, the confidence intervals hit the actual parameter. This one doesn't, right? We can see that this interval lies too large, right? It definitely overestimated. Right? Some of the other ones come kind of close, but they don't fall away too far. They're still hitting that actual parameter value. Is there anything I can clarify? And would anyone like a moment to write anything down? So these two things are definitely things I think you should have in your notes. It's kind of containing the proper verbiage and how you should kind of set up things properly here. So interpreting a confidence interval. To interpret a C% confidence interval for an unknown parameter, say we are C% confident that the interval from one value to another value captures the actual value of the population parameter in context. So it depends on your context and the parameter you're dealing with, means, proportions, and whatever. Interpreting confidence levels. To say we are 95% confident is shorthand for if we take many samples of the same size from this population, about 95% of them will result in an interval that captures the actual parameter value. Right, so we have confidence interval and confidence level. They're very similar, but not the same. Right, they're kind of containing similar information, but phrased differently. Can you raise your hand if you need a moment to write this down? The confidence level tells us how likely it is that the method we are using will produce an interval that captures the population parameter if we use it many times. The confidence level does not tell us the chance that a particular confidence interval captures the population parameter. Right, so this doesn't tell us something about a particular interval from a sample. It just says overall, kind of like we would expect 95% of these SRS's intervals to capture the population parameter. It's not singling out a particular interval from a particular sample. Instead, the confidence interval gives us a set of plausible values for the parameter. We interpret confidence intervals and confidence levels and confidence intervals in much the same way, whether we are estimating a population mean, proportion, or some other parameter. We particularly focus on mean and proportion in this text, but these same ideas could be applied to other parameters such as standard deviations, variances, and the like, quartiles if we wanted. See, we need a moment to write anything down. So why settle for 95% confidence when estimating a parameter? Right? Why not go for 100? Right? The price we pay for greater confidence is a wider interval. If we want to be more confident, we have to consider a larger amount of data. When we calculated a 95% confidence interval for the mystery mean mu, we started with the estimate plus or minus the margin of error. Right? Our estimate came from the sample statistic X bar. Since the sampling distribution of X bar is normal, about 95% of the values of X bar will lie within 2 standard deviations, 2 times sigma X bar, of the mystery mean mu. That is, our interval could be written as 240.79 plus or minus 2 times 5, which is equal X bar plus or minus 2 sigma X bar. This leads to a more general formula for confidence intervals, statistic plus or minus critical value times standard deviation of statistic. The critical value is essentially within how many standard deviations do you want to be of the mean. All right, and so this is all going to kind of tie back into our normal distribution calculations, right? Kind of using the 68, 95, 99, 7 rule, determining proportion of a distribution under the curve, right? Kind of working forwards and backwards using table A. So again, that stuff's not going away. So we need a moment to write anything down. So calculating a confidence interval. The confidence interval for estimating a population parameter has the form statistic plus or minus critical value times standard deviation of statistic, where the statistic we use is the point estimator for the parameter. Properties of confidence intervals. The margin of error is the critical value times standard deviation of statistic. So if you're asked for the margin of error, that plus or minus number, right? And you'll see that on statistics on like TV and stuff. They'll say, this is what we found, and we have a margin of error of plus or minus some value. Right? It's our margin of error. This is how it's found. The user chooses the confidence level, and the margin of error follows from this choice. Right? Larger confidence level, right? Larger the margin of error might be. The critical value depends on the confidence level and the sampling distribution of the statistic. Because again, the critical value depends on the proportion, essentially the proportion under the curve that you want, right? Greater confidence requires a larger critical value, right? You're covering more of the area under the curve. The standard deviation of the statistic depends on the sample size n. Right? Whether it's the standard deviation for a sample mean or a sample proportion, the sample size comes into play. Right? Larger sample size, smaller variance. Does anyone need a moment to write anything down? So there are two important cautions to keep in mind when constructing and interpreting confidence intervals. Our method of calculation assumes that the data came from an SRS of size n from the population of interest. Right? It kind of assumes that we sampled well. The margin of error in a confidence interval covers only chance variation due to random sampling or random assignment, meaning errors that happen purely by chance, not because of undercoverage or because of response bias or non-response, right? Those are things that could create larger margins of error that this method is not accounting for. Okay, so it assumes that we sampled well, and it assumes that our errors are only due to chance. Does anyone need a moment to write anything down? And that brings us to the end of the lesson for today. All right, as far as our presentation is concerned, all right. We can begin to understand how to determine the point estimate and margin of error from a confidence interval. We can somewhat determine or figure out how to interpret a confidence interval and confidence level in context. We can describe how the sample size and confidence level affect the length of a confidence interval, larger sample size, smaller confidence interval, right? Confidence level, depending on how big of a confidence level, larger confidence interval. And explain how practical issues like non-response, undercoverage, and response bias can affect the interpretation of a confidence interval. Right? If we have these things such as non-response, undercoverage, and response bias, that's going to affect if we can even interpret the confidence interval. If we realize we didn't sample well or our sampling is kind of off, right, we're going to have problems. We might have to try again. Okay. Is there anything I can clarify? Is there anything you'd like me to go back to a previous slide? So then, moving forward, tomorrow we will be seeing some more examples and participating in some practice problems, as we have been doing kind of after our lesson days. So please be ready for that tomorrow. And also, practice problems are available. You're more than welcome to look at those. They might be a little more useful after tomorrow's lesson, where you'll see some more examples. But you're welcome to try them and take a look at them. And other than that, if there's anything else I can help you with or support you with today, if you have any questions about past assignments or grades or anything like that, please stick around, let me know. And other than that, I will see you tomorrow and have a wonderful rest of your day.